What if I told you Earth was just hit by a solar storm that scientists never saw coming? No warnings, no predictions, just a sudden blast of charged particles slamming into our planet's magnetic field. A type of space weather event researchers now call a stealth storm. And here's the shocking part. These invisible solar eruptions are becoming more common. Today, we're breaking down what happened, why NASA and NOAA missed it, and what stealth storms teach us about the hidden dangers coming from our sun. On November 20th, NOAA's space weather forecast looked normal. They detected solar wind flowing from a coronal hole, a dark, cooler, low-density region of the sun's atmosphere where magnetic field lines open up and let plasma escape. This fits perfectly with where we are in the 11-year solar cycle. The sun recently passed solar maximum and is now heading towards solar minimum, a quieter period where coronal holes become more common. So far, so predictable. But then, something else was coming. This solar wind was only the prelude to a much bigger, hidden threat, a coronal mass ejection, or CME, the kind that usually triggers GPS glitches, radio blackouts, and power grid instability. Except this one didn't look like a typical CME. It was almost invisible. To understand how this thing snuck up on Earth, you need to know how CMEs normally work. Magnetic fields in the sun's corona can twist, tangle, and snap, a process called magnetic reconnection. This unleashes electromagnetic energy and ejects massive blobs of solar material into space. Scientists usually detect these explosions using coronagraphs and satellites, but stealth CMEs are different. Researchers discovered they form at higher altitudes in the corona. They appear only as tiny bright or dim patches. They leave almost no trace in intensity data. Even when spotted, their origin point can't be identified. One team found the main factor behind their invisibility was their large spatial spread, not their altitude. Weak signatures were so subtle that even specialized instruments nearly missed them. Some stealth storms were visible only from NASA's stereo spacecraft, orbiting in a different position, meaning Earth-based observers literally had the wrong angle. This is why the CME that hit Earth on November 20th arrived unannounced. After reanalyzing multiple stealth storms, researchers realized they had underestimated structural changes in the corona, the value of comparing images taken at different times, the need for advanced processing techniques to catch subtle brightening or disturbances. A 2021 study revealed that several stealth CMEs had clear early signs, but those signs were only visible when looking from another angle in space. Now scientists recommend comparing long-interval solar images, combining brightness and intensity data, scanning for weak, sudden changes in coronal structure, using multi-angle observations whenever possible. If these steps are adopted, stealth storms may finally become predictable. Although this unexpected CME caused only a temporary spike in geomagnetic activity, the result was stunning. Auroras reached farther south than usual, all the way to Denmark and Maine. The sky exploded in purples and reds across the northern hemisphere, a beautiful reminder that even when the sun is quiet, it can still surprise us. And Earth is always just one stealth storm away from a major space weather event.